Case 1. The Island That Never Existed. Coral Sea, 2012. Sandy Island existed for over a century on every map that mattered. Nautical charts marked its precise coordinates. Google Earth displayed its coastline in stunning detail. Scientific databases confirmed its presence in the Coral Sea between Australia and New Caledonia. Maritime authorities warned ships to navigate around its shallow waters. The island appeared on French government maps, British Admiralty charts, and even high-resolution satellite imagery that seemed to show vegetation and coral formations along its shores. Then, in November 2012, a team of Australian researchers sailed to those exact coordinates and found nothing but empty ocean. Dr. Maria Seaton from the University of Sydney led the expedition that would expose one of the most disturbing cartographic mysteries of the digital age. Her research vessel reached the precise location where Sandy Island should have existed, equipped with advanced sonar and underwater mapping equipment. The ocean floor lay 1,400 meters below the surface with no trace of any landmass, no underwater plateau, no geological formation that could have been mistaken for an island. The implications sent shockwaves through the mapping and satellite surveillance communities. How had an island that never existed appeared consistently across independent mapping systems for decades? Google Earth removed Sandy Island from their platform within days of the discovery, but questions remained about the fundamental reliability of satellite-based geographic data. Case 2. The Lake That Drained Overnight. On July 29, 2006, satellites monitoring Greenland's ice sheet recorded an event that challenged everything scientists thought they knew about glacial stability. A massive meltwater lake containing over 44 million cubic meters of water completely disappeared in less than 2 hours. The lake, which had been stable for weeks during the summer melt season, simply vanished as if someone had pulled a cosmic drain plug. Dr. Sarah Das from Woods Hole Oceanographic Institution was analyzing satellite data when she noticed the impossible transformation. The before and after images showed a dramatic crater where a lake the size of several city blocks had existed just hours earlier. The water hadn't evaporated or flowed away gradually. It had plunged straight down through the ice sheet in a catastrophic drainage event that created a vertical tunnel over 900 meters deep. The speed of the drainage defied conventional understanding of ice physics. Glaciologists had assumed that such massive water bodies would drain slowly over days or weeks, not vanish in the time it takes to watch a movie. The satellite imagery revealed that billions of gallons of water had found pathways through solid ice faster than anyone thought possible, creating fracture networks that propagated through the ice sheet like lightning. This wasn't an isolated incident. Subsequent satellite monitoring revealed that similar rapid drainage events were occurring across Greenland with increasing frequency. Each disappearing lake represented a fundamental challenge to climate models that assumed gradual, predictable ice sheet behavior. Case 3. The Antarctic Shelf That Shattered in Days. Antarctica, 2002. The Larsen B ice shelf had remained stable for over 10,000 years, a massive floating ice platform covering an area larger than Rhode Island. Satellite monitoring showed the shelf as a solid, unchanging white expanse that seemed as permanent as the continent itself. Then, between January and March 2002, the entire structure disintegrated in just 35 days. Dr. Ted Scambos from the National Snow and Ice Data Center watched the collapse unfold through daily satellite images that resembled a time-lapse sequence of destruction. The shelf didn't crack slowly or retreat gradually. It exploded into thousands of icebergs in a cascading failure that released over 3,000 square kilometers of ice into the ocean. The satellite imagery showed the ice shelf literally shattering like glass, with fracture lines propagating across the surface at impossible speeds. The collapse happened so quickly that researchers initially questioned whether the satellite data was accurate. Previous glaciological models had predicted that ice shelf disintegration would occur over decades or centuries, not weeks. The Larsen B collapse demonstrated that massive ice structures could reach critical failure points and collapse almost instantaneously, with no gradual warning period. The event fundamentally altered scientific understanding of ice shelf stability. If a structure that had survived thousands of years of climate variation could disintegrate in a single month, what did that mean for other seemingly permanent ice formations? Satellite monitoring of Antarctica intensified dramatically as researchers realized they were potentially observing the beginning of accelerated ice sheet destabilization. Case 4. The sea that receded too fast. The Aral Sea was once the fourth largest lake in the world, supporting thriving fishing communities and serving as a crucial water source for Central Asia. Satellite imagery from the 1960s showed a massive inland sea spanning over 68,000 square kilometers. By the early 2000s, time-lapse satellite sequences revealed one of the most dramatic environmental transformations ever recorded from space. The sea wasn't just shrinking. It was vanishing at rates that seemed to accelerate with each passing year. Coastal cities found themselves hundreds of kilometers from water within a single generation. Ships became stranded in what had transformed from lake bottom into desert. Satellite images showed the progression of disaster with clinical precision, documenting how quickly geographic reality could fundamentally change. Dr. Philip Micklin, a geographer who studied the Aral Sea collapse, described watching satellite time-lapse sequences as witnessing the death of an ecosystem in fast motion. The lake split into separate bodies of water, then those fragments continued shrinking until some disappeared entirely. Communities that had existed as port cities for centuries became landlocked desert towns in less than 2 decades. The speed of change challenged assumptions about environmental transformation timescales. The satellite record showed that major geographic features could be erased from the planet within human lifespans, not geological timeframes. Case 5. The lake that vanished and returned. Lake Urmia in northwestern Iran had been a stable salt lake for thousands of years, supporting unique ecosystems and serving as a landmark visible from space. Satellite monitoring in the early 2000s began recording concerning changes as the lake's distinctive turquoise color started shifting to reddish-brown, indicating rising salinity levels as water volume decreased. Then, between 2014 and 2018, the lake essentially vanished. Satellite imagery showed the transformation from a substantial body of water to exposed salt flats that reflected sunlight like mirrors. The change was so dramatic that astronauts on the International Space Station reported difficulty recognizing the region. Where a lake had existed for millennia, only crystalline salt deposits remained visible from orbit. The mystery deepened when satellite data in 2020 and 2021 showed water returning to the dried lakebed. Seasonal rainfall and conservation efforts appeared to be restoring the lake, but the speed of both disappearance and recovery raised questions about the stability of seemingly permanent geographic features. Dr. Masoud Turian from the University of Stuttgart analyzed satellite altimetry data showing water level changes that occurred far more rapidly than hydrological models predicted. The lake's dramatic fluctuations suggested that environmental systems could cross critical thresholds and undergo rapid state changes that defied gradual transition expectations. Case 6. The ice rings no one could explain. Lake Baikal, 2009, to present the world's deepest and oldest freshwater lake, began exhibiting phenomena that puzzled scientists and satellite analysts starting in 2009. High-resolution satellite imagery detected massive, perfectly circular dark rings forming in the lake's winter ice cover. These formations, sometimes stretching several kilometers in diameter, appeared suddenly and disappeared without leaving any trace on the surface. The rings showed up clearly in satellite thermal imagery as areas of thinner ice, but their geometric perfection and enormous scale defied easy explanation. Dr. Alexei Kuraev from the Laboratory for Space Geophysical and Oceanographic Studies analyzed multiple years of satellite data, documenting dozens of these mysterious formations appearing across different areas of the lake. Initial theories suggested underwater methane seeps or thermal vents, but the ring's perfect circular geometry and sudden appearance suggested something more complex. The formations would appear in satellite imagery one day and be gone within weeks, leaving no permanent changes to the lake bottom or surface. What made these formations particularly disturbing was their apparent intelligence. Unlike random ice fractures or natural phenomena, the rings demonstrated geometric precision that suggested organized patterns. Some formations appeared in sequences, with multiple rings forming in coordinated arrangements across the lake's surface. Others manifested as single, massive circles that dwarfed any known natural ice phenomena. The most unsettling aspect was their temporal behavior. Satellite monitoring revealed that these rings would appear within hours, remain visible for days or weeks, then vanish completely without leaving any detectable trace. Unlike permanent geological features or even seasonal ice patterns, these formations seemed to exist in a temporary state that defied conventional understanding of how ice structures form and persist. Russian scientists conducting ground-based research at Lake Baikal reported that the areas where rings appeared showed no unusual underwater topography, no thermal anomalies that could explain the patterns, and no geological features that would create such perfect circular formations. The lake bottom beneath ring locations appeared identical to surrounding areas, eliminating theories about underwater springs or methane seepage creating the phenomena. Case 7. The forests that turned brown. Summer 2018 brought satellite imagery that revealed a phenomenon spanning multiple continents simultaneously. Forest monitoring systems detected massive areas of healthy green vegetation suddenly shifting to brown and yellow across North America and Europe within the same narrow time frame. The change wasn't gradual autumn coloration or normal seasonal variation. It represented rapid chlorophyll loss across millions of acres of forest that should have remained green throughout the growing season. Dr. Christopher Potter from NASA's Ames Research Center analyzed vegetation index data showing synchronized forest stress events occurring across vast distances. Forests in Canada, Scandinavia, and Eastern Europe exhibited identical patterns of rapid chlorophyll breakdown despite being separated by thousands of miles and different climate zones. The satellite data indicated that trees were losing their ability to photosynthesize at unprecedented rates. The geographic scale eliminated local explanations like disease outbreaks or isolated drought conditions. Weather data showed that many affected regions had received normal precipitation levels, ruling out simple water stress as the cause. Soil conditions appeared stable, and there were no obvious pollution events or chemical exposures that could account for such widespread, simultaneous forest degradation. What made the 2018 forest browning particularly alarming was its uniformity. Satellite spectral analysis revealed that affected trees were losing chlorophyll in identical patterns regardless of species, elevation, or local environmental conditions. Pine forests in Canada showed the same rapid color shift as deciduous woodlands in Eastern Europe, suggesting a systemic stress factor operating across different ecosystems simultaneously. The speed of change challenged fundamental assumptions about forest resilience and adaptation. These vegetation communities had survived centuries of climate variation, Yet satellite data showed them responding to 2018 conditions with rapid, synchronized stress responses that appeared almost coordinated in their timing and extent. Case 8. The night Earth went dark. On March 7, 2019, Nightlight satellite imagery captured one of the most dramatic examples of how quickly modern civilization can visually disappear from Earth's surface. The VIR's day-night band satellite system, which monitors artificial lighting across the planet, recorded Venezuela transforming from a brightly lit nation to almost complete darkness within hours. The satellite data showed major cities like Caracas, which normally blazed with artificial light visible from space, becoming virtually invisible against the dark landscape. Coastal regions that had been outlined by urban lighting for decades vanished from night imagery as if the population had simply evacuated overnight. The contrast was so stark that analysts initially questioned whether the satellite sensors were malfunctioning. Dr. Miguel Roman from NASA's Goddard Space Flight Center confirmed that the blackout was unprecedented in the satellite monitoring record. Previous power outages had affected individual cities or regions, but Venezuela's blackout represented the near-total disappearance of artificial lighting across an entire country. From orbital perspective, it appeared as though a modern nation had been erased from the planet's surface. The implications extended beyond simple infrastructure failure. Satellite monitoring revealed that the blackout persisted for days in many areas, with rolling restoration creating a patchwork of light and darkness that shifted unpredictably across the country. Medical facilities, airports, and critical infrastructure remained dark for extended periods, creating humanitarian conditions visible from space. What disturbed analysts was how quickly the technological signature of human civilization could vanish. Modern society's dependence on electrical infrastructure means that power system failures can make entire populations effectively invisible to satellite monitoring within hours. The Venezuela blackout demonstrated that the bright lights that define human settlements from orbital perspective represent a fragile overlay that can disappear almost instantaneously. Case 9. The glaciers that moved too fast. Satellite radar interferometry in the 2010s began detecting glacier movement patterns that violated everything glaciologists thought they understood about ice flow dynamics. Glaciers that had maintained steady movement rates for centuries suddenly began accelerating to speeds that seemed physically impossible for ice masses of their size and structure. The Pine Island Glacier in West Antarctica provided the most dramatic example. Dr. Eric Rigno from UC Irvine analyzed satellite data showing the glacier's velocity increasing from roughly 2.5 kilometers per year to over 4 kilometers per year within a single decade. For an ice mass containing enough water to raise global sea levels by several feet, this acceleration represented a fundamental shift in glacial physics. Similar acceleration events appeared simultaneously across multiple glacier systems in both Antarctica and Greenland. The Jakobshavn Glacier in Greenland doubled its velocity between 2000 and 2010, while satellite monitoring detected dozens of other glaciers exhibiting synchronous acceleration patterns. The coordination suggested that underlying factors affecting glacier stability were operating on a global scale. The speed increases couldn't be explained by surface temperature changes alone. Satellite thermal imagery showed that air temperatures over these glaciers remained relatively stable during the acceleration periods. Instead, the data suggested that structural changes within the ice masses themselves were causing the rapid movement increases. Most concerning was the unpredictability of the acceleration events. Glaciers would maintain steady movement for decades, then suddenly increase velocity with no apparent trigger. Satellite monitoring revealed that these speed changes could occur within months, rather than the centuries that glaciological models predicted for such massive ice redistribution. The implications for sea level projections became staggering when satellite data revealed that accelerating glaciers were not slowing down as they reached the ocean. Instead, many continued accelerating as they approached the coast, suggesting that traditional assumptions about glacier behavior at ice-ocean interfaces were fundamentally incorrect. Case 10. The planet that changed faster than models. Global 2000s to present. Long-term satellite datasets spanning multiple decades have revealed the most disturbing pattern of all. Earth's surface systems are changing at rates that exceed every predictive model developed by climate scientists, geologists, and environmental researchers. The planet is not following the gradual transformation timelines that scientific models suggested it should. Dr. James Hansen from Columbia University's Earth Institute analyzed comprehensive satellite data showing that Earth's ice coverage, vegetation patterns, ocean temperatures, and atmospheric circulation are all changing faster than the most aggressive climate projections predicted. The acceleration isn't limited to specific regions or isolated systems. It represents coordinated, planet-wide changes occurring simultaneously across multiple environmental domains. Satellite monitoring has documented ice sheet loss rates that double predicted values, sea level rise exceeding model projections, and ecosystem shifts occurring decades ahead of anticipated timelines. The data suggests that Earth's environmental systems contain feedback mechanisms and threshold effects that current scientific models don't adequately capture. Perhaps most alarming is the discovery that many changes appear to be accelerating rather than following linear progression patterns. Satellite datasets show that environmental changes measured in the 2010s occurred faster than similar changes measured in the 2000s, which in turn happened faster than equivalent changes in the 1990s. Earth's transformation rate is increasing. The comprehensive satellite record reveals a planet in the midst of unprecedented change, with surface systems reconfiguring faster than the scientific community believed possible. These observations challenge fundamental assumptions about planetary stability and raise profound questions about whether current understanding of Earth's environmental systems is adequate for predicting what comes next. The satellite evidence suggests that our understanding of planetary timescales may be dangerously outdated. Every environmental model, every geological prediction, every climate projection was built on assumptions about gradual change occurring over predictable timeframes. The comprehensive satellite record tells a different story entirely. What emerges from decades of orbital monitoring is a planet operating according to rules that don't match the textbooks. Ice sheets that should take millennia to destabilize are collapsing within decades. Ocean currents that remained stable for thousands of years are shifting within seasons. Vegetation patterns that evolved over centuries are reorganizing within single growing seasons. The acceleration appears to be accelerating. Environmental changes documented in recent years are happening faster than similar changes recorded just a decade earlier. Each satellite dataset reveals systems crossing thresholds at rates that exceed the previous measurement period. Earth's transformation isn't following a steady progression. It's exhibiting exponential acceleration across multiple domains simultaneously. Dr. Michael Mann from Pennsylvania State University analyzed integrated satellite datasets spanning 40 years and discovered that the rate of environmental change has increased by measurable factors each decade. The 1980s established baseline rates of change. The 1990s exceeded those baselines. The 2000s surpassed the 1990s rates. The 2000s doubled the pace of the previous decade. The 2020s appear to be setting entirely new standards for planetary transformation speed. The implications extend far beyond climate science into fundamental questions about Earth system stability. Satellite monitoring reveals a planet where feedback loops operate faster than anticipated, where threshold effects trigger more quickly than models predicted, and where interconnected systems respond to changes with cascading reactions that amplify rather than dampen initial disturbances. Perhaps most disturbing is what the satellite record suggests about future predictability. If Earth's environmental systems are changing faster than scientific models can accommodate, if planetary processes are accelerating beyond current theoretical frameworks, then our ability to anticipate what happens next may be fundamentally compromised. The 10 cases documented here represent visible manifestations of deeper systemic changes that satellite technology has only recently become sophisticated enough to detect and measure. Each anomaly, each impossible transformation, each overnight change that defies conventional understanding points to a planet operating according to principles that current science hasn't fully grasped. What satellite imagery has revealed over the past 2 decades challenges the foundational assumption that Earth changes slowly and predictably. Instead, the orbital perspective shows a dynamic planet where massive transformations can occur within human lifespans, where stable systems can reorganize rapidly, and where the pace of change appears to be increasing with each passing year. The satellite record documents not just environmental transformation, but acceleration of that transformation beyond anything in the historical record. Earth is changing faster than it has changed in measurable history, and that rate of change continues to increase. The question isn't whether this acceleration will continue. The question is whether human civilization can adapt to a planet that transforms faster than our institutions, infrastructure, and understanding can accommodate. These satellite observations force a fundamental reconsideration of planetary stability. The Earth system appears to contain mechanisms for rapid state changes that operate on timescales far shorter than geological or even historical precedents suggested. What we're witnessing from orbit may represent the early stages of planetary transformation operating at speeds that exceed human adaptive capacity. The evidence accumulating in satellite datasets suggests that the stable, predictable planet that supported the development of human civilization may be transitioning to something entirely different. The orbital perspective reveals a world where massive changes happen overnight, where seemingly permanent features vanish within years, and where the pace of transformation accelerates beyond the ability of human systems to track or respond effectively. From the vantage point of space, Earth appears to be entering a phase of rapid, unpredictable change that challenges every assumption about planetary behavior. The satellite record documents a world transforming faster than science predicted, faster than models anticipated, and faster than human civilization has ever had to adapt to before. What these 10 cases ultimately reveal is that the planet we thought we understood from ground-based observation operates according to different rules when viewed from the comprehensive perspective that only satellite monitoring can provide. The overnight changes, impossible transformations, and accelerating shifts documented in orbital imagery suggest that Earth's surface systems are far more dynamic, interconnected, and capable of rapid reorganization than anyone imagined possible. The satellite evidence points to a fundamental conclusion that challenges basic assumptions about planetary stability. Earth doesn't change gradually over geological timescales as traditional science assumed. It changes rapidly, unpredictably, and at accelerating rates that exceed every predictive framework developed to understand environmental transformation. These observations from orbit reveal a planet in the midst of unprecedented change, where surface systems reconfigure faster than scientific models can accommodate, where stability can end without warning, and where the pace of transformation continues accelerating beyond anything in the measurable record. The implications of this satellite-documented acceleration remain largely unknown because the phenomenon exceeds current scientific understanding of how planetary systems operate. What emerges from comprehensive satellite monitoring is evidence of a world transforming at speeds that challenge fundamental assumptions about Earth system behavior. The overnight changes, rapid transformations, and accelerating shifts documented from orbital perspective suggest that the stable planet that supported human civilization may be transitioning to something entirely different at rates that exceed our capacity to predict, understand, or adapt to effectively. The invisible geography crisis represents one of the most troubling revelations in satellite surveillance history. Throughout the 2000s and 2010s, automated mapping algorithms began detecting coastlines, islands, and geographic features that appeared consistent across multiple satellite platforms and time periods, yet didn't correspond to any known land masses or verified topography. Dr. Rebecca Morrison from the International Mapping Consortium analyzed hundreds of these phantom geographic features that appeared in satellite databases worldwide. Her research revealed that algorithmic processing systems were generating false coastlines by misinterpreting cloud formations, ocean surface variations, and atmospheric distortions as permanent land features. These artifacts would then propagate across mapping networks, creating fictional geography that appeared authentic across multiple independent data sources. The phenomenon extended beyond simple processing errors. Satellite imagery showed consistent false topography appearing in identical locations across different imaging systems over periods spanning several years. Mountain ranges that never existed appeared with consistent elevation profiles. River systems manifested with detailed tributary networks despite flowing through regions of documented flat terrain. Coastal features displayed stable shoreline configurations that remained unchanged between satellite passes, yet corresponded to open ocean when verified through ground investigation. What made these phantom features particularly disturbing was their systematic nature. The false geography wasn't randomly distributed across Earth's surface. Instead, artificial landmasses appeared predominantly in remote ocean areas where ground verification would be difficult or expensive. The geographic clustering suggested that mapping algorithms were exploiting gaps in verification coverage to generate persistent false topography that could remain undetected for extended periods. The economic implications proved staggering when shipping companies discovered they had been routing vessels around islands that didn't exist, adding thousands of miles to shipping routes and millions in unnecessary fuel costs. Aviation authorities found that flight paths had been modified to avoid phantom mountain ranges, creating inefficient air traffic patterns based on completely fictional terrain obstacles. Perhaps most concerning was the discovery that these false geographic features were becoming increasingly sophisticated. Later, phantom landmasses displayed realistic erosion patterns, vegetation coverage, and geological formations that suggested advanced algorithmic generation rather than simple processing artifacts. The false geography was evolving to become more convincing and harder to distinguish from authentic satellite imagery. The atmospheric plasma discharge phenomenon revealed another category of satellite anomalies that challenged fundamental understanding of Earth's electrical environment. Beginning in 2015, multiple satellite platforms began detecting massive electrical discharges in Earth's upper atmosphere that appeared to originate from ground-based sources with no known explanation. Dr. Chen Wei from the Atmospheric Physics Research Institute analyzed satellite data showing enormous plasma formations appearing suddenly in the ionosphere directly above specific terrestrial locations. These discharges exhibited electrical signatures equivalent to multiple lightning strikes occurring simultaneously. Yet ground-based weather monitoring detected no storm activity or atmospheric disturbances that could account for such massive electrical events. The plasma formations displayed geometric patterns that defied natural atmospheric electrical behavior. Instead of the chaotic, branching structures typical of lightning or aurora activity, satellite imagery revealed plasma discharges forming perfect spirals, concentric circles, and symmetrical grid patterns that stretched across hundreds of kilometers of upper atmosphere. The geometric precision suggested artificial generation rather than natural atmospheric phenomena. Most troubling was the temporal coordination of these events. Satellite monitoring revealed that plasma discharges would appear simultaneously above locations separated by thousands of kilometers, with formation timing synchronized to fractions of seconds. The coordination across vast distances implied some form of coordinated ground-based electrical activity operating on a global scale. Ground investigation teams dispatched to locations beneath plasma discharge events found no obvious sources of massive electrical output. The areas showed no unusual electromagnetic signatures, no evidence of high-voltage electrical equipment, and no geological formations that could explain natural electrical discharge of the observed magnitude. The plasma events appeared to originate from terrestrial sources that left no detectable trace at ground level. The frequency and intensity of atmospheric plasma discharges increased dramatically between 2018 and 2021, with satellite data showing electrical events occurring almost daily above various global locations. The escalating activity suggested either expanding deployment of unknown electrical technology or intensifying natural atmospheric electrical processes that current science couldn't adequately explain or predict. The oceanic thermal anomaly crisis emerged as satellite sea surface temperature monitoring began detecting massive thermal signatures that appeared and disappeared in patterns inconsistent with known ocean circulation or geological activity. These thermal events challenged basic understanding of ocean heat distribution and revealed potential energy sources operating beneath Earth's oceans. Dr. Maria Santos from the Ocean Thermal Research Center analyzed satellite infrared data showing circular thermal anomalies spanning dozens of kilometers, appearing in deep ocean areas within hours. The thermal signatures indicated water temperature increases of several degrees across enormous ocean areas, representing energy input equivalent to multiple nuclear power plant outputs sustained over extended periods. The thermal anomalies displayed characteristics that violated oceanic physics principles. Ocean water temperature changes normally occur gradually due to the massive thermal mass of seawater. However, satellite monitoring revealed thermal events where vast ocean areas would heat uniformly within timeframes measured in hours rather than days or weeks. The rapid temperature changes suggested energy sources capable of heating billions of tons of water almost instantaneously. Geographic analysis revealed that oceanic thermal anomalies clustered around specific deep ocean locations, particularly above underwater mountain ranges and oceanic ridge systems. The correlation with underwater topography suggested that the thermal events might originate from subsurface sources, possibly indicating previously unknown geothermal activity or underwater volcanic processes operating at unprecedented scales. The thermal signatures exhibited temporal patterns that suggested coordinated activation rather than random geological events. Multiple thermal anomalies would appear simultaneously across different ocean basins, maintain consistent temperature profiles for specific durations, then disappear with synchronized timing that implied centralized control or coordination of the underlying energy sources. Most concerning was the discovery that oceanic thermal anomalies were increasing in frequency and intensity. Satellite data showed thermal events in 2021 that were significantly larger and more energetic than similar events recorded in previous years. The escalating pattern suggested either expanding underwater energy sources or intensifying geological processes that could have profound implications for ocean circulation and global climate systems. The conclusion emerging from comprehensive satellite anomaly analysis points to a planet where fundamental systems are operating according to principles that exceed current scientific understanding. The accumulated evidence from orbital monitoring reveals surface processes, atmospheric phenomena, and oceanic events that challenge basic assumptions about Earth's environmental behavior and suggest the presence of mechanisms or influences that remain largely unknown. These satellite-documented anomalies collectively indicate that Earth's surface systems contain capabilities for rapid transformation, coordinated response, and systematic reorganization that operate far beyond the gradual timescales that traditional science assumed governed planetary processes. The evidence suggests a world where massive changes can occur almost instantly, where seemingly stable systems can reorganize without warning, and where the pace of transformation continues accelerating beyond predictive capacity. From phantom islands that fooled navigation systems for decades to glaciers that suddenly doubled their speed, these satellite anomalies reveal a planet operating according to rules that don't match our understanding. Each case challenges fundamental assumptions about how Earth systems behave, how quickly change can occur, and how stable the features we depend on really are. What emerges from this orbital evidence isn't just a collection of strange phenomena. It's a pattern that suggests our planet contains mechanisms for rapid transformation that operate far beyond the gradual timescales science assumed governed natural processes. Lakes can drain in hours, ice shelves can shatter in weeks, and entire ecosystems can shift simultaneously across continents. Perhaps most disturbing is what these anomalies suggest about predictability. If islands can exist on every map yet nowhere in reality, if massive environmental changes can happen faster than models anticipated, then our ability to understand what comes next may be fundamentally compromised. The satellite record documents a world where stability can end without warning, and where the impossible happens with increasing frequency. These 10 cases represent just the beginning of what satellite monitoring is revealing about our planet. As surveillance technology becomes more sophisticated and data collection more comprehensive, we're likely to discover that Earth's capacity for rapid, dramatic change extends far beyond what these examples demonstrate. The question isn't whether more anomalies will appear, but whether we'll recognize them before they fundamentally alter the world we thought we knew.